The potentiometer on the prototyping board is connected to three pins on the microcontroller. One end of the potentiometer is connected to voltage, the other end is connected to ground, and the middle pin is connected to a signal pin, in this case analog pin 3. We can read the value using the SAID command, so I can turn the knob or the dial of the potentiometer. We can see that it goes from 0 to 1023. Now we're going to want to send this output to SNAP, and the protocol for SNAP is that we would put in a header, and which would be a 2-item list in this case, and the header has to be put in a join command with a comma used as a separator. And if we do that, then we see that we have a list consisting of the word dial that's read by the when I receive command at SNAP, and then the second item of the list is the output of the potentiometer. So now that we've verified that the potentiometer is working, always a good idea before going any further, we can now bring in the broadcast command, and when microblock is started, we'll send this over to SNAP, and this is what it's going to look like. When I connect SNAP to the microcontroller, once again I can see that the data is coming in. Now when I receive dial reads the header and then passes the second item in the list, the output of the potentiometer, along to data, and I can see that with the say command. I'd like to be able to use this to guide the direction of the needle of the gauge, and so if I take away the say command, I can tell it to point in the direction of the gauge, and I've adjusted it so that when the gauge is all the way over, it reads at 1023, it's all the way over the left, and then as I move it back to 0, it's all the way in the other direction. So to the right at maximum and to the left at minimum. Now I've accomplished this by dividing the data, the maximum range of the data, 1024, by 180, because I'm trying to shift it back and forth across the 180 degree range. And then I'm rounding it because I want it to be able to be stable and not fluctuate. So I can also tell another sprite named value to adjust as I adjust the dial. In this case, I want the minimum to be 0 and the maximum to be 100%, and I've accomplished that by taking the data and dividing by 10.24, because I want to round to the nearest 100th percent, that is 0.01, and then I round that so that I get a nice percentage. And if I combine the two so that I'm doing both, then the needle can swing all the way over, and I get a readout on the gauge, and then as I go back and forth, I can see both a numeric output and I can see a numeric an analog output, the movement of the needle. And in this way, we can take external physical dials and knobs and switches and represent them as a dashboard on the screen of SNAP, building up whatever device or mechanism that we wish to control and monitor.